Welcome to our video tutorial on picture patterns, extensions of the skeleton tower. In this first problem, we want to determine the number of blocks needed to create the 100th figure. We're going to approach this two different ways. First, we're going to look at the overall dimensions of the big rectangle. In the first problem, it's 3 by 4. In the second problem, it's 4 wide by 2, 4, 6 tall. Then we've got 5 by 2, 4, 6, 8. And finally we have 6 wide by 2, 4, 6, 8, 10 tall. But we're missing a rectangle. So in the first picture we're missing a 2 by 3 rectangle that's been removed. Then we're missing a 3 by 5 rectangle that's been removed. And then we're taking away a 4 by 1, 2, 3, 4, 5, 6, 7 rectangle. And finally 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So when we go to write the rule, it's two numbers multiplied together minus another two numbers multiplied together. So let's take them one at a time. First, we have the 3, the 4, the 5, and the 6. In that first set of parentheses then, to go from 1 to 3, 2 to 4, 3 to 5, 4 to 6, that's n plus 2. The other way you could look at that is 3, 4, 5, and 6 is an arithmetic sequence because it's going up by the same amount each time. Its slope is 1, hence the 1n, and going backwards one term, we would get 2, hence the plus 2. For our next number that goes in parentheses, we have 4, 6, 8, and 10. Now this one we probably want to write out as an arithmetic sequence to see it just a little bit better. So 4, 6, 8, 10. Notice on this one the slope is 2. So it's going to be a 2n that goes in those parentheses. Again though, we want to go back in time one to figure out the b, and the 0th term would be 2. So in that parenthesis should be the expression 2n plus 2. Here's the first. We are going to look at the numbers 2, 3, 4, 5. Now we could write that out as an arithmetic sequence. Here it comes. 2, 3, 4, 5. That sequence has a slope of 1. So in the parentheses we're just going to put a 1n, which is just an n. And going back in time to the 0th term, we would have a 1 there. So it's going to be n plus 1. The other way of looking at that is to go from 1 to 2, 2 to 3, 3 to 4, 4 to 5. You're just simply adding 1 to the n. And finally, our last set of parentheses, we're looking at the numbers 3, 5, 7, 9. So if we write out 3, 5, 7, 9, notice it has a slope of 2. So it's going to be a 2n. And then going back in time one term, going 3 previous here would be a 1, so that's going to be a 2n plus 1. Of course, you could also plug into y equals mx plus b to figure those things out, but that is our a sub n. Now we want the 100th picture, so we have to plug in. Please show the plug-in. The 100th picture then is going to be 102, when we plug in n equals 100, times 202, when we plug in n equals 100, minus 101 times 201. Just to be sure that everybody sees where that's coming from, 102 is the yellow, 202 is the magenta, 101 is the green, and 201 is the blue. So now if we calculate that out, I'm getting my calculator here, 102 times 202 minus 101 times 201, I'm getting 303. So our final answer to this problem is that the 100th figure would contain 303 of those unit squares. Let's make that look a little bit nicer. There we go. A 100 is equal to 303. That would be our final answer. Please make sure you show the a sub n along the way. Now, we could approach this problem completely differently and still arrive at the same answer. So here's our second situation. Same problem. Let's approach it different. I'm going to look at the vertical number of blocks. I'm highlighting them in blue right now. The vertical blocks. And then separately, I'm going to consider the horizontal blocks that I'm highlighting in magenta. Now, some folks might find this to be an easier approach to the problem. Whichever approach works for you, go for it. The first picture has 4 blocks plus 2 blocks, where the 2 are the magenta and the 4 are the blue. Then we've got 6 plus 3, and then we've got 8 plus 4. Wow, this is a nice pattern that's popping up. And then we have 10 plus 5. Now, I'm going to color code just to make sure we're all on the same page, but you can go through and not color code. It's up to you. Just be organized and make it clear how you're arriving at your answer. Put a little dividing symbol in here. There we go. Just to space them off from each other. And notice that we're adding two things together. So for this rule, it's just going to be something that I'm going to highlight in blue plus something else that I will highlight in magenta. Now, be careful on this. So for the blue, we've got the following list of numbers. Think about it as an arithmetic sequence. 4, 6, 8, and 10. Notice that its slope is 2. So in that blue set of parentheses, well, I don't have parentheses there, but I will. It's going to be 2n, and then go back in time 1. So that's going to be a 2, and we'll have 2n plus 2. Now, of course, you could also do that by plugging into y equals mx plus b. We showed both strategies. Sometimes on homework keys, I use the y equals mx plus b. But here, I just want to show how quickly you can go with that shortcut. And then in magenta, we have the numbers 2, 3, 4, and 5. That is an arithmetic sequence, but maybe you can catch it as just n plus 1 really fast. If you don't see it as n plus 1, well, you could look at it as having an arithmetic sequence with a slope of 1, hence the 1n, and then go back in time 1, and the b would be the plus 1. Now this rule looks completely different from the rule that we had originally, but I claim it's going to get us the same result. So when we plug in 100 for n, it turns out to be 202 plus 101, and that just comes from plugging in n equals 100. And if you add up 202 plus 101, we get 303. So either strategy, we get the same number. When you're checking your answer on homework keys, please make sure you're looking at the 100th or 50th or whatever picture. Your rule might be completely different than what's written on the key, but regardless, you might come up with the exact same answer. That's fine. Now we're going to look at one more problem. This is one that sometimes gives people some issues. What happens when they're stacked like this? Well, remember what Gauss said. Gauss liked to take something big and stack it with something small. So first what I'm going to do is illustrate that we want to base everything around the center column. So I'm going to scribble the center in blue. And now what I want to do is I want to take the right-hand side and pair it on top of the left-hand side in each of these pictures. So if I were to take these two blocks right here, I could move them over here and come up with another 2 blocks. And then if I take this single block right here, I could move it up here and come up with another block. And really then, this picture would have these things gone, and there's what we're working with. Look at how simple this is now. The dimensions of that should be relatively easy to identify. It's a 3 by 3 rectangle. So let's do the same thing here. We're going to take these 3 blocks and we're going to stack them right here. Boop, 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 boop. There we go. Then we're going to take these 2 blocks and stack them right over here. Boop, boop. Then we're going to take this last block, stack it right there. Boop. And really we've gotten rid of this stuff. So there's the picture we have left. And it's a 4 by 4 rectangle. Or square. Third picture, we take the tall and pair it with the small. Whoop, 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 boom, boom. You don't have to have the perfect drawing there. Then take the next large one with 3, put it right here. Boop, boop, boop. Take the 2, put it right here. Boop, boop, boop. And take the single block and put it right there. We can then get rid of this stuff. And notice the third picture is now a 5 by 5 square. Well, it's something being squared. It's something times itself. To go from 1 to 3, 2 to 4, 3 to 5, we're just adding 2. So this rule turns out to be n plus 2 times n plus 2, or you could write that as n plus 2, the quantity squared. Don't forget to answer the question though. So the 100th figure would have 102 squared number of cubes, or little squares, and 102, that number being squared, is 10,404. So if you follow that approach that Gauss took and that we took with the skeleton tower, and pair something large with something small, it evens out and you get a rectangle in the end. Hopefully picture patterns are making sense, and hopefully these 2 examples helped you better understand this concept. Thanks for watching this tutorial on picture patterns, extensions of the skeleton tower.